very good morning to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering in Institute of Aeronautical Engineering, and I'll be dealing the subject robotics. And my today's topic is discussion on the question bank from the module 1, which represents the robot applications. Right? Coming to the module 1, let us first discuss the first question, that is, explain the various factors in gripper selection and design. Explain the various factors in gripper selection and design. So what do we mean by the selection of the gripper? What do we exactly mean by the term gripper? Gripper is nothing but it is the hand of a robot, right? As the human has the hand to hold any of the object or to do the work based on the hand, in the same way, a robot also has a hand which is being called as a gripper. Now, in the robot, we have various types of grippers. That is, this gripper selection will be done depending upon the type of the application. That is, for example, if we need to pick and place the object from one place to the other, we require a hand gripper type of the end effector. Whereas if we want to suck the object and place it in some other place, we require a vacuum type of the gripper. Whereas, for example, when we come across the electrical circuits, right, where we need to hold the small chips which are in very minute shape, so those particular type of the chips will be moved from one place to the other with the help of a magnetic gripper. That is, the gripper is made of magnet where it attracts the chip, and due to which the movement of the magnet, that is a very minute magnet, will become very easy. So, in this particular topic, we will be discussing about the factors which are used for selecting the gripper and how that particular design of the gripper is being made. So, as I've told you, the gripper for an robot is an automation system where it acts with several critical factors where it is having the effective and efficiency in its application. Right? Depending upon the application, the effective and efficiency of the gripper will be playing a very important role. Depending upon the type of the application, for example, we can use it in material handling, we can use it in assembly disassembly, we can use it for thermal spraying, we can use it for welding purpose, we can use it for medical appliances, etc. So, depending upon the type of the application, the gripper selection will be done and the design of that particular gripper will be done. So, here, let us discuss about the objectives, the type of objectives for the gripper. So, first we need to study about the shape and size of the gripper. That is, the shape and size of the gripper may be in a round shape, or it may be in a square shape or rectangular shape, depending upon the size of the object. Right? Depending upon the size of the object, depending upon the shape of the object, and depending upon the type of the industry or organization, we design the gripper shape and the size. If we are working in a large scale industry, in some industries, right, where you have large production quantities to be handled, so there you require a large scale size of the end effector, that is a gripper. So whereas when you go for the, as I've told you, in the electrical circuits, there you require a very minute small type of the magnetic gripper, right? Or when you go for a spray painting type, there it is just used to hold the spray. So the size and shape is being changing. So depending upon the type of the application, or depending upon the type of the organization or the industry, or depending on type of the shape and size of the object, the gripper shape will be changing. right? Next one is the weight. What do we mean by weight here? We have to pay concentration when we are designing a gripper. We need to have a concentration on the weight, that is how much weight it can hold. If we are designing a robot whose end effector cannot hold a for example, let us have in a large scale industry, we have an object to be lifted which is around 50 kgs weight, and the design of the gripper can hold only up to 30 kgs or 25 kgs. So when we are making the robot to act on that particular 50 kgs robot, will it withstand? No, it will not withstand. It will break. Right? The robot's end effector will be breaking. So in order to reduce all this particular constraint, we need to take care about the weight. The payload capacity of the gripper should be considered. So in order to, when we are considering the payload capacity of the gripper, then only we can ensure that the object will be withhold with the help of the robot in a proper way without slipping or damaging the object, or without damaging the robot's end effector itself, right? That is known as the weight selection objective. The next is the material. What is the type of material we are using to design the robot? That is also a very important term which we need to consider, right? So here, when we are handling a soft object, right, and when we are using the gripper which is rigid, so will that particular object sustain? No, it will get damaged, it will break, or there will be some pores being occurred when the robot is holding the soft object. So when we are designing or when we are selecting the gripper, we need to take care of the material also, right? That is, we will dictate the type of the gripper mechanism, whether it is a soft type, rigid type, or a adaptive type, right? Depending upon the type of the object, we will be deciding the material of the end effector gripper. For a soft type, we will be selecting a silicone or some other soft material. For a rigid type, we will be going for that particular constraint material. In the same way for the other materials. So the selection of the material for the end effector gripper is also very important. Right. Next, moving on to the surface texture. What do we mean by surface texture? Surface texture means the smooth or the rough surface may require different friction coefficient or the gripping mechanism. That is, when we are selecting the robot's end effector, we need to consider the type of the surface texture, or when we are considering the type of the surface texture, based on that only the gripper's manufacturing or the gripper designing will be done. That is, for a soft surface texture, we will require a smoother gripper design. For a rough surface texture, we require a rough type of the nailed type of the surface texture of the robot end effector gripper. So the shape and the size, the weight, the material, and the surface texture of the robot's end effector gripper plays a very important role in designing and selecting the gripper, right? Next, gripper type. As I've told you, we have 4 types, that is mechanical gripper, vacuum type of the gripper, magnetic gripper, and adhesive gripper. Depending upon the type of the application, we will be selecting these type of the grippers. When we come across the mechanical gripper, what do we mean by mechanical gripper? Mechanical gripper means the gripper is in the form of the finger of the human, right? The gripper is in the form of the hand and fingers of the human. That where it can do, it can hold 2 or 3 or multi-fingered grippers, where we have 2 type of the grippers, or we maybe a 3 types of the gripper, or it may be a multi-finger type of the gripper. Now generally, we use the mechanical type of the gripper in the large scale industries where we are holding heavy objects. Right? When we are holding heavy objects in the large scale industry, generally we use mechanical type of the gripper. That is, these fingers act as the jaws and it grip the object which are suitable, depending upon the application, and it will place it in its respected place. Now again, as I've told you, depending upon the type, number of fingers, the applications will be changing. If it is to be done for a spray painting, there you require only 2 fingers required, where in between these particular 2 fingers like this, you can place this particular spray, or when you hold the electrode, in the same way you can do. But when you need to hold a larger circular object, will this particular two-ended gripper be sufficient? No, we require multiple type of fingered gripper which can hold the object perfectly without causing damage by slipping. Right? If we are having only 2-ended or 3-ended fingered gripper, what happens when we come across a circular object? It gets slipped easily. So when we are going for a multiple type of the finger grippers, then it becomes easy for handling the circular and soft rotary objects. Clear? Next, coming to the vacuum type of the gripper. Generally, this vacuum type of the gripper is in this form. See here. This is the robot. This is the manipulator, where we are having this as the end effector, where this is acting as a suction gripper. This is acting as a suction gripper. Generally, we use this particular type of the vacuum gripper in pharmaceutical applications or in medical applications, where it sucks the waste material and throws it in the desired position. That is, the waste whatever we are filling in the containers or in the packets, plastic packets, it is being sucked in this form, right? It is being sucked in this form and it is being thrown in the required destination, right? So here generally it is used for smooth and non-porous surface. It is the vacuum type of the gripper generally is being used for smooth and the non-porous surfaces, right? Coming to the magnetic type of the gripper, as I've told you, generally, this particular type of the magnetic type of the grippers are especially used in electrical applications, right? Generally, the magnetic type of the gripper are mostly used in the electric type of the application, where handling the ferromagnetic material will become easy. When we have very small minute chips in we cannot hold those particular gripper with the finger type of the gripper or with the vacuum type of the gripper. So when we are using the magnetic type of the gripper, these particular chips or the minute circuits will not drop from the end effector of the robot. And this particular magnetic type of the gripper is used for mostly ferromagnetic type of the materials. So generally for the handling the ferromagnetic type of the material which requires a physical contact, we will be using a magnetic gripper, which makes them more useful in situations where material surface integrity is important. Clear? Next, coming to the adhesive gripper. What do we mean by the term adhesive gripper? Adhesive gripper means what? Where the objects are being gripped and are ideal for dedicated material or surfaces where mechanical force might cause damage, right? That is, the materials which are ideal for delicate material, that is, for delicate materials generally we use the adhesive type of the gripper. The materials which are very delicate and whose surfaces are getting damaged due to the force being applied on that particular object, there we go for an adhesive type of the gripper, right? Clear? Next, moving on to the third concept is the force requirement. So when we come across the discussion of selection of the gripper or designing of the gripper, one more important concept which we need to remember is the force. Like how much is the amount of force being applied through the end effector gripper on the required object. That is also very important. If the robot's end effector is applying more force, gripping force on the object, that particular object either slips or it gets damaged. Right? That particular object is either slipping or it gets crushed in the fingers of the robot. So the force requirement is very important when we are designing a robot's end effector. That is the gripping force. The gripping force is very important, where it requires to hold the object without causing damage or slippage, which will be calculated based on weight and surface characteristics. The gripping force will be calculated based on weight and surface of the object. Right? Based upon the weight and surface of the object, the calculation will be done and that will be inserted to the robot as a program, and according to that particular program only, the robot will hold the object or move the object from one place to other without applying more amount of the force, where the objects get damaged or get slipped from the end effector. Right? Next is the release mechanism. Release mechanism means what? At what stage it should release. Right? The sudden release of the end effector will also cause damage. Yes or no? So at what stage the end effector gripper should release the object? That is, what is the start position and what is the end position should be remembered by the robot. In that way, the programming has to be given. That is, the force required to release the object should also be considered. Right? The force, whatever has been required to release the object, should also be considered in a special form so that it doesn't damage the object by sudden release or the sudden movement of the robot end effector. Clear? So gripping force and release move mechanism are two of the important concepts which we have to keep in mind before designing the robot's end effector. Now the fourth one is the workspace and the reachability. What do we mean by workspace and reachability? That is, depending upon the range of motion or depending upon the accessibility, we need to design the robot. That is, when the robot doesn't have a proper degree of freedom, then can it move appropriately? No. That is, when we are designing the robot, we have to consider the degree of freedom, degree of movement of the robot's end effector, so that the work whatever has been assigned to the robot will be completed with good efficiency and accuracy. If that particular robot's end effector is not having a proper degree of freedom, then it cannot move the object from one place to the other with a good efficiency or a good accuracy. Right? That is, a gripper should have enough reach and degree of freedom to interact with the objects across the entire work area. Right? So the range of motion is also very important. We need to consider, we need to calculate the degree of freedom and we need to assign that programming to the robot. Right? Next is the accessibility. Accessibility means what here? Right? The design must allow the gripper to access objects in tight or confined spaces if necessary. Right? The robot should have an access to allow the gripper to access the object in tight or the confined space if required. Next, environmental conditions. At what environment, if we come across different environmental conditions, according to those particular environmental conditions, we need to design our end effector. So if we are using the robot in the thermal power plants, right? If we are using these robots in the thermal power plants, we need to design the robot in such a way that the material whatever is being used for the end effector gripper should withstand all that extreme temperatures. right? The material, whatever we are using for the robot end effector gripper, should withstand all the extreme temperatures, right? For example, power plants, turbines, near boilers, etc. So where heat generation is extreme, right? Generally where there is extreme heat temperature being generated, there we come across the operating temperature. There in that particular concept we design the robots end effector. Or when we come across the humidity and dust, for example, if we go to the areas where we have high humidity and where we have high dust, what happens? The gripper gets rusted out, right? So when we have less moisture or when we have more moisture content, what happens? The sealing design gets damaged, it gets harshed. So keeping all this in constraint, the environmental factors like moisture can affect the gripper's performance, right? Keeping the humidity and dust in constraint, the environmental effects may damage or affect the gripper's performance, which may become harsh in conditions, right? Next, cleanliness. What do we mean by cleanliness? Right? Generally, these particular the robots end effector should be very clean when it is working in the applications like food handling, pharmaceutical, hygienic and crucial, uh, necessitating special materials and design considerations are very important, right? That is when we are designing the robots end effector, the end effector should be very clean such that it can handle the food in the food sector, it can be good at the pharmaceutical sector, or it can be good at the hygienical in crucial. So the cleanliness is also very important when we are selecting the material and designing of the robot end effector. Speed and precision requirement. Speed and precision requirement is at what speed the robot is been acting. If it is acting at higher speed, what happens? It gets damaged, right? If it is acting at a very slow speed, what happens? The time consumption is more and the cost consumption will increase, right? So considering all this, some applications such as high speed manufacturing lines or the required fast actuating times are also to be considered while designing. And precision means what? We need to take care of the accuracy. When any particular object is being designed as output we are getting, we need to take care that that particular product's output will be more accurate, that it should have a particular constraint of precision. That is assembly tasking or the complex assembly tasking or the delicate objects, when we consider it should be more precise, right? And compliance and adaptability. What do we mean by compliance and adaptability? Compliance and adaptability means the design of the end effector should be done in such a way that there should be some variation, right? From one robot to the other robot's end effector, there should be a variation where that particular variation will again depend upon the shape of the object, the size of the object, the position of the object, right? So we should take care of the compliances when we come across the design of robot end effector. That is, some gripper should be designed so that there will be a slight variation in object with respect to its shape or the position, preventing damage in case where exact position isn't guaranteed. Or when we come across the adaptive grippers, in adaptive grippers what we are using, we use sensors, right? In the adaptive gripper type, we will be using the sensors, or we will be using a flexible materials to adjust the gripper based on the object properties. Depending upon the property of the object, we will be using this particular type of the grippers. That may be a sensor type or that may be a flexible material type, which allows the handling of diverse objects without reconfiguration, right? Next is the material of the gripper. It may be a durable material or it may be a gripper pad type of the material. It is when we are using a durable material, its wear and tear will be more. right? The gripper must be made of durable material to withstand the wear and tear in industrial settings. That is very important, right? When we come across the gripper pads, soft materials, generally like rubbers or silicone, will be used. Right? When we are coming across the gripper cord, soft materials such as rubber or silicone will be used for handling in order to prevent the damage of the object. So in this way, we need to select the material of the gripper. Right. Next is the power source. How is the power source being generated to the end effector for its movement? So that particular power source will be done with the help of the actuators. That is, it may be a pneumatic actuator, or it may be a hydraulic actuator, or it may be a electrical or the mechanical. Again, here also, depending upon the type of the application, we will be using this particular type of the actuators. That is, when we have air as a constraint, we will be using a pneumatic actuator, or when we have fluid as a constraint, we will be using a hydraulic type of the gripper, or when we have a motor type of the actuator, that is a stepped motor, or we use the electrical type of the actuator, right? That is depending upon the type of the application, depending upon the type of the robo, and depending upon the type of the industry or organization, we come across the selection of the actuator, which acts a very important role, because with the help of the actuator movement only, the robot end effector will be moving, right? With the help of the actuator movement only, the robot's end effector will have the movement, right? So these are very important concepts. When we come across the principle of air being sucked inside and releasing high amount of pressure, which moves the cylinder head in the forward direction, gives rise as a result of the movement of the end effector. In the same way, when fluid is being sucked inside the piston, some amount of the pressure is being generated, which with the help of that particular pressure, the cylinder head is being moved and the robot's end effector starts moving, right? Next is the cost and maintenance. The cost and maintenance is also very important. That is, we need to take care that the budget will not be more and the maintenance also will be less. So in that form, we need to plan for designing and selecting the material for the robot end effector. That is, the cost of the gripper must fit within the overall budget, right? The cost of the gripper must fit within the overall budget of the robot system without compromising with the critical performance aspects, right? Without compromising with the critical performance aspects, we need to take care of the cost of the gripper. Next is the maintenance requirement. Maintenance means what? Again, the design should allow for easy maintenance, especially in environment with high wear or contaminations. When we come across the high wear and contaminations in industry, we should take care that the maintenance will be low, right? So overall, we have seen that the gripper selection and the design is very important concept for the robot, because the whole project, that is the robot's objective, is only done with the help of the movement of the gripper. That whether it is picking and placing, whether it is assembly, disassembly, whether it is spray painting, whether it is welding, whether it is in any form of hospitality or any agriculture field, whatever it is, gripper is the term which is holding the object and move. That is, for example, we as a human, if we are not having hand, we are of no use. In the same way, the robot without an end effector gripper is of no use, right? Hope you have understood about the selection criteria and design of the gripper. Right? Moving on to the next question. Compare between polar configuration robot and a jointed arm configuration robot. What do we mean by polar configuration robot and what do we mean by jointed arm configuration robot? Yes. Here in the polar configuration robot means what? It comprises of the rotational base, right? Here in the polar configuration robot, it comprises of the rotational base which is in the rotational form, right? Where it is a combination of both rotary plus linear movement, right? The polar configuration robot is a combination of both rotary as well as the linear movement. That is known as the polar configuration, and this is working on the principle of resembling a partial sphere or a dome. That is, its working and principle is based on the partial sphere or the dome, which offers two rotational and one linear. Here we have two rotational and one linear movement being taking place in the polar configuration, which we also called as RRRP. That is two rotational and one linear prismatic. Right? That is, here the polar configuration robot comprises of the rotational base, where a vertical arm is being having a rotary as well as the linear movement. That is, it can move in the rotary direction or it can move in the linear direction, right? Where it has two rotation and one linear movement. That is the reason we are calling it as a RRP configuration. Right. Next, moving on to the next one, that is articulated robot, means jointed arm robots. Here there is no linear movement being taking place. In this particular type of the robot configuration system, we don't have linear movement. We have all the movements which is being done in the rotation movement. That is, three rotational movements we will be having. Right, this particular robot will be having only three complete rotations, whereas zero linear movements. That is, it composes of a series of rotary joints connected by the rigid links, which resembles in a human arm. It is a multiple degree of freedom with rotation joints at the base of the shoulder, elbow and the wrist. Its structure allows the flexibility and versatility as the RRR configuration. Right? Now, when we come across the degree of freedom for the polar and the jointed arm, here the polar has 3 degrees of freedom, whereas the jointed has 4 to 6 degrees of freedom. Why here we have only 3 degrees of freedom? Because it has 2 rotational and 1 linear, whereas here we have all the rotation movement of the robot is only in the rotational direction. So it will be having 4 to 6 degrees of freedom depending upon the number of joints. Right? Here, this purely depends upon the number of joints. And this has an extension of the arm and the vertical motion. That is the reason it has only 3 degrees of freedom. Whereas, the jointed arm configuration has 4 to 6 degrees of freedom, where it is moving in the 3 rotational joints, which purely depends upon the number of joints and the wide range of complex movement. Right. Next, moving on to the working envelope, working principle. How does the polar configuration work and how does the jointed arm configuration work? Generally, as I've told you, this particular type of polar configuration is mainly depending upon the spherical or the dome-shaped working area. Right? It provides a large spherical or dome-shaped working area which is suitable for tasking, which requires reach in all the directions from a central point. Whereas the jointed arm configuration provides a large or more flexible working envelope, right, which allows more dynamic reach and manipulated in the 3D environments. Right. Coming to the applications, the polar configurations are generally used for picking and placing, welding, assembly operations in large areas. Commonly in environments required wide coverage but not intricate movement. There we are using the polar configuration. Whereas the jointed arm configuration are generally used near manufacturing, assembly, packing and precision applications. Right? The polar configuration is generally being used near the picking and placing the objects or near welding operation or near assembly operations. Whereas the jointed arm is generally used near manufacturing, packing or the precision applications. Right? And this particular type of the polar configuration is not used near the intricate movement, whereas here the jointed arm has a complex task like painting, welding, material handling and assembly in confined spaces, right? The jointed arm has the operations to be done like painting, welding, material handling and assembly in only confined spaces. Next, coming on to the flexibility. How flexible is the polar configuration and how flexible is the jointed arm configuration? That we need to concentrate on. So generally when we come across the polar configuration is less flexible and it is limited to degree of freedom. Right? It is limited to degree of freedom and it is less flexible. And it also has the linear movement limit or constraint, right? The polar configuration is less flexible and it has a limited degree of freedom and it has a limited linear movement or a constraint for the linear movement, whereas the jointed arm is highly flexible. Right? The jointed arm is highly flexible and it is able to perform the complex operations. Right? And it is able to handle complex operations. Right? Jointed arm. Whereas the polar arm is less flexible, it has less degree of freedom and it does not compliance the linear movement, whereas the jointed arm is highly flexible and it can also operate complex operations. Right? Generally, the polar configuration is best suited for straight forward or repetitive tasks. Right? Generally, the polar configuration has been preferable for the repetition task only for the forward movement of the robot's end effector. Whereas the jointed arm is being used in the awkward spaces or where we have complexity for the robot's end effector to work. There the jointed arm configuration will be acting very appropriately. Right? Coming to the precision, the polar configuration has the adequate precision, whereas the jointed arm configuration has a high precision. Right? The polar configuration has adequate precision, whereas the jointed arm configuration has the high precision. Coming to the cost, the polar configuration is less costly compared to that of the jointed arm because it is simple in construction and it has few degrees of freedom, whereas the jointed arm configuration is complex in construction and it is highly flexible and it has more advanced control systems, due to which it is more costly than polar configuration. Right? Jointed arm is more costly than polar configuration because here we will be using high-end control systems and the construction of the jointed configuration is more complex compared to that of the polar and it is also highly flexible. Whereas in the polar configuration it is a very simple design and it also has very less degree of freedom, due to which it is less costly compared to that of the jointed arm. So in the overall, the polar configuration systems are generally used in a small scale industry where we have a simple operations to be done or when we have a repetitive operations to be done. There we use polar configuration. Whereas in the large scale industry where we need to work on the larger objects, we go for the jointed arm robot, which is having higher degree of freedom and which is more flexible and which is having more control systems. Right? So this is about the difference between the polar configuration and the jointed arm configuration. Right? So these are the references we have been referred. So in today's topic, we have discussed about the design and construction and the selection of the material for the end effector gripper and what is its use and how does it work. And we have seen the difference between a precision and the jointed arm configuration robot. Right? So in the next class, we will discuss about the question bank from the module 2. So This is all for today. Hope you have understood the session. Signing off for today, Dr. G. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.